Okay. That's number 13 in part 1. Part 1, 13. Part 1, 13, 1, negative 2. Now 9x minus y equals 12. And minus 9x plus 4y equals 6. Okay, now for the first time, it's the first two. We'll eliminate through addition. We will eliminate the x terms. It sounds better, the x terms, than the variable terms. When you're generally speaking about x and y, you speak about the variable terms. But when you know that it's x, then it might resonate better with you. You eliminate the x terms by addition. Nothing else will get rid of them but addition to each other. Gone. Addition is 4y, take y. Addition is commutative. Now I like to do that way because I'm free to do it either way, because addition doesn't matter whether I add first to second or second to first. 4y take y. But here 12 plus 6 is better. Now calculating 4y take y is 3y. 12 plus 6 is 18. Now using the dividing property of equivalence, meaning I can divide by 3. Careful here, it's not, the answer is not 3, the answer is 6. 18 divided by 3 is 6. And I put it in a bracket. I go 9x minus the new value we know of y equals 12, and I mark my equation. Let's get rid of that now. Mark that I'm using this right now to get the y value. No. I've used him already. What's that? What on earth is that? Oh yeah. Yeah, I haven't used anything yet, have I? So, I'm making a model here now. I know y is 6. Yeah, but this is my first. There's been no substitution, so let me be clear here. Now, let's identify. Let's focus on what's happening regarding elimination. Now, elimination stage is complete. And now we enter the reign, the era of substitution. And if we're entering substitution land, substitution time, we need to start saying which one we're using, star it, we're going to use that fella there. Okay? And then our y's come back, or our x's come back that we had eliminated. They're coming back, they're being resurrected. So here we go. 9 times the unknown x minus the known and substituted here by 6 equals 12. Now we're going to isolate x by going through our linear algebra steps. Always deal with the loose constant first by popping them across. How do we do that? We're using the, so first I can get rid of that by calculating. Okay, and then you can go add 6 to both sides, the additive property of equivalence. And that implies, by division, that x is 2, and he's ready for substitution as well. Now we have a y and an x. But what I want to do is I want to arrange them as 2, 6 like this, nice and tidy. Go back to my substitution chart and go, oh look at this, I have to use the bottom one now. Minus 9 times the first plus 4 times the second is squiggled to 6. Negative 18 plus 24 is the same as 24 take 18 is indeed equal to 6, and we have verification of our solution. Okay, so now we know the answer is x, y, and you're not aiming for Picasso type work here. So no matter how, every journey is different, every time you do it is different. So I run out of space on my board and I'm going to use the side here to plate it up and say, indeed, I know now the answer is definitely 2, 6. And when I write it as a pair, like that, I'm really committing. And go one step further and put it into a box. So the examiner finds it straight away. And now I know question 14. The answer is 2, 6. I'm going to speed up now. And if you don't like that, you can slow me down. Okay, speeding up at the same time, not skipping too many steps. Let's see. So you can call this a spanner in the works, a little bit of a challenge. So 2 ways of doing it. One is to do what you always do and just add them, and 2 and a half is 3x. The other thing is double top and bottom to clear the fractions. I've just noticed that if I do add them, I won't have a fraction, I'll have an integer. So I can actually just go ahead and add them and say, whew, the fractions are gone away. 2 and a half is 3x equals 12. Divide by 3. X is 4, put in a bracket. It's the end of our substitution. It's the end of our elimination. You can call it that. End, elimination, start, substitution. Starting substitution, going to the top. Now, these questions, the way they'll be designed, if they're like this, will bring back wholeness. They will take a fractional calculation and you'll be pleasantly surprised, as we're about to see. A half, and if you weren't for any reason, then you could go and do the first plan there, which would have been to double both. Because you see, doubling would produce equivalent equations and it wouldn't make a blind bit of difference to your answer. But we don't have to, because half times 4 is going to be an integer. So I'm using the top. 2 into 4, 2 into 4 is 2. Now you might divide across by 2, but you really don't need to. I don't like that it's negative 6y. But they are integers. I'll just split it into 2 different methods. Okay, so the person on the right hand side says, you know what, I really like him to come across here, even though it's because I first and foremost want positive y's. I said, yeah, but that means the 8 has to come back. Fine, the 8 comes back and you get negative 6. And then you divide by positive 6, giving negative 1. It'll be the exact same answer the other way. But I like this methodology. It reminds us that in inequalities we really want to avoid a negative y, because then we have to flip the inequalities and it's more complicated if you've done inequalities before. But look, if you haven't, and this is equal, the maths of equals, which is easier, then you say leave him alone and move that 2 here. Subtract 2. And now you divide by negative 6. And if you want to put that negative 6, it's a coefficient, but if you want to put him in brackets, just remind yourself that whole fella there lifted down. Or you could say, well, once I get to here, I'll change the signs of both sides. That's a really handy one. change sign of both sides. That's one we should keep an eye on. We're allowed to use this when there's an equals. So 6y equals minus 6. And then the minus stays up rather than dropping under. Either way, no matter what you do, you're going to end up with minus 1. Minus 1 here, minus 1 the previous way I did it, minus 1 no matter what way you do it. So y is minus 1, x is 4. Okay, notice how it's kind of, if you had a rubber and a pencil, you could do the same thing there. You could turn the x equals 4 into xy equals 4 negative 1. We're going to verify the second one. Now you have 2.5 times 4. For those who hate this, that you could have, the option to double at the very beginning to get rid of the fractions was a very valid option that you could have taken. Either way, things are working out nicely for us. 2.5 times 4 plus 6 times y. Whoop. Can sub him now as well. This is the double. Actually, the nice way of thinking of this is that whatever you put there is what you're subbing. And the fact that there's a mark there at all says it has been used. And now I'm subbing this here. Because I was going along and I did something silly here and I wasn't ready for a substitution here. I wrote 6y. But this is another thing to say here, is that this is a double substitution. So we're going to put negative 1 there, because that's the value where I hope is right. Put a squiggle here if you want. And 4 2.5s. 2 2.5s is 5, and then double it again is 10. So if we're multiplying by 4 and it's tricky, double and double again. A double double. 4 is a double double. 6 times negative 1 is negative 6. Is indeed equal to 4, and we know it's our solution. xy. Okay. Eight x plus 6y. Where am I going? That's for 8x plus 6y equals 2. 2x minus 6y equals 3. Okay, let's speed things along here now. So that'll be 10x. I was going to write down the 10x I've calculated and simplified already. That'll be 5. Ooh, this is a tricky one. X equals a half. Subbing x. 8 halves plus 6y equals 2. That's 4. Really. 8 halves is 4. It looks like it. Looks like we're on a crazy fraction thing here. Okay, we're getting 6y equals negative 2. Y equals negative 2 over 6. Notice I've dragged the minus off the numerator. Okay, which is equal to negative a third. Well, if we have any doubts or anything, we have the fact that we're going to verify now up here with xy. Which is a half and negative a third. Two times half minus 6 times negative a third equals 3, hopefully. 2 times a half is 1, minus by minus is plus, 3 into 6 is 2, is indeed equal to 3, so we have the right answer. Okay. But I'm looking at these and I'm going, you know, that's not simple because the two known calculated values came out as, both of them came out as fractions. This is a negative unit fraction, this is a positive unit fraction because there's 1 on top. But fractions nevertheless. Okay, let's presume that was question 16. And you've no way of really telling as you look at the original question whether it's going to come out as fractions or not. But I will say this, unless they're very nicely designed and specifically designed, they're going to come out as fractions. And once you're putting in a fraction here, especially if it's a messy fraction, not a unit fraction, then we learn how to use our calculator later on to actually take all the pain of the mess of the calculation out. So there will be ones that are very messy, and if you're doing higher level, junior cert, which you hopefully all are, then we will be ready for that and we'll move on to that, maybe when we revisit algebra later on. Okay, so half negative a third has been verified. What's going on? Oh yeah, so 17 and 18. 17. I can't believe I'm doing these out, but it just goes to show how much homework he had. It's a good thing I cancelled part 2 and part 3. There's enough homework here. Good thing it was the weekend as well.